Hey folks, and welcome to today's session. So we're going to log in first to the Anaconda prompt. So I've just pressed my start button, Anaconda's loading up, and I'm going to go to where I have my notebooks already saved. So the D drive is where I should be going. I'm going to go CD, GitHub, CD, satellite image analysis. I'm going to activate my environment. So Conda activate SEER for satellite image analysis. And now I'm going to open up my Jupyter notebook. So it's just loading. Now we're going to go into the notebook section. We're going to go to week 4, and in here we have this notebook called Intro to Shapely Geometry Objects. And essentially today what we're going to do is we're going to go over a package which is very central to spatial analysis within Python, which is called Shapely. And you might have heard of other packages such as GeoPandas, and basically they reuse shapely geometry objects as kind of the fundamental spatial building block for that package. And therefore, before we get to that more advanced package, we're going to just cover the basics here, okay? So essentially what we're going to do is we're going to work through a little bit of general information, and we're going to go through points, lines, and polygons within this particular session, okay? So this is going to be important because by the time you actually get to analysing satellite imagery, you want to be able to extract information. So you maybe have an image, maybe you want to extract the water areas or some other areas that you might have object identified using whatever method, and then you want to extract that as spatial information in order for you to then either count or sum or average that underlying information that you've got. So you're going to need to know how to manipulate these underlying geometries. So we can handle these objects using Shapely. The fundamental types of geometric objects are going to be, well, they're called points, curves, and surfaces within the Shapely package. You can think of those as points, lines, and polygons, essentially. And Shapely really allows us to do some pretty cool things. So we can assess relationships between different things. So that could be that we want to measure the distance, want to measure whether one polygon, so one shape contains a set of dots, other points that we've got. We maybe want to check whether two polygons intersect or touch or overlap. And then we're also able to do more advanced operations, okay? So we're able to do things like take a buffer around a point or a line, and then we're also able to do things like intersect different types of geometry objects, okay? So we're able to take different polygons, get the intersecting part, and we're able to use that information, okay? So this is kind of the nuts and bolts approach to doing some of those very kind of basic and pivotal spatial processing techniques, which you might have done in things like ArcMap or QGIS, but here I'm going to show you how you do it within a Python environment from a kind of bottom-up approach. And actually, I think it will help you kind of reinforce how you understand these processes within those other classes which you've taken. Okay, so you might have done Introduction to GIS, but they probably haven't got into the nuts and bolts as to how the computer processes some of those spatial techniques. And today, hopefully, this might give you a bit more of an underpinning as to what's happening under the hood. Okay, so let's get into points. Now, according to Shapely, a point has basically an interior set of exactly 1 point. So a single point consists only of a single point, otherwise it can't be a point anymore. It consists also of a boundary set exactly of no points, so if it has any sort of boundary, it's not a point anymore. And it has an exterior set of all of the points. So this is kind of the logical definition of what a point is in this particular case. I think it's probably easier for you to just understand it as a tuple set of coordinates, okay? So you can think of this in a graph space. You might have an x and a y axis, and you can think of this point here as being at position 1 on the x-axis and position 3 on the y-axis, okay? And you can do the same for these other types of tuples that we've got here. So first what you need to do before you get started is you actually need to install Shapely onto your virtual environment if you haven't already. So you need to run this. It might just take about 30 seconds to a minute to install. I'm not going to run it now, but you guys should definitely, you folks should definitely run that on your machine so that you actually have this package to access. And then once you've done that, what you're able to import is specifically this this point function here. Okay, so you say from from the geometry part of the package Shapely, import the function point. Now point has a very specific set of arguments which it takes, essentially, so it's an x and a y coordinate. You can actually look at all of this in greater depth if you go to the Shapely user manual here, so you'll see that the actual information is shared via this link in the introductory part of this notebook, and you can go in there and you can look at all of this in greater detail. I'm just going to be kind of picking out the key points of it and explaining it to you today, okay? But you can go into lots of detail here to understand exactly all the different types of functions that are available to these objects. So look, we've put those two coordinates in, so we have a single point and it's created a Shapely geometry object, and you'll begin to recognize that this here, the fact it says it's a point, it's in capitals, and it has the following set of coordinates, you'll begin to recognize that structure in the future as a Shapely geometry object, okay? And that means we can do various things to it. Now we're currently agnostic towards the coordinate reference system that we're using, so Shapely just kind of ignores that for now, and we're just getting started with this mythical point that we've created, okay, and it exists in this space. We can also view that within actual geographic context, so there's not much here, there's just a single dot, and that's because it's a single point in this XY axis space here. Obviously that's going to look different once we get to lines and polygons. They're going to look closer to things that you would recognize as being either a line or a shape. And we can actually just check that geometry object that we created by using this geometry geom_type function, and it's just going to return here that object, my point, is a Shapely geometry object because we've used this geom_type function on it, and it's returned that it is a point, okay? So now you've created this object, you're able to check exactly what that is. So whenever I say geom, this is short for geometry, okay? And obviously this geometry in this context is just a collection of tuple points, or just a single point, and then from that, essentially, we can form either a single point, or we can form a line string, or a polygon. We can use this function repeatedly to create lots of different objects. So here we have myPoint_2, and then we have the Shapely geometry object just being printed to the console. We also then are able to do cool things within Shapely, so we're able to measure the distance between these 2 points. So if you kind of thought of before as just being kind of a spatial model for allocating what spatial objects things are within Python, well actually here we're able to do the interesting bit, which is that we're able to take measurements between stuff, or we're able to check the distance, okay? And we can do a whole range of different things once we are able to do these basic operations. So that's kind of what I'm showing you today, the basic operations of working with this package, and you can apply that however you want at a later stage. So the distance between my point here and my point 2 is going to be this unit here, so it's 1.02, and we don't have it in a particular coordinate reference system at the moment, so I'm not going to give it a particular unit, but if you're doing this in WGS 84, these would be decimal degrees. If you're doing this in another type of projected coordinate reference system, then this would be a unit such as meters. Okay. So as point is just a single coordinate, its area is going to be 0, okay? And its length is also going to be 0. We also are able to take the bounds, so this is going to provide the minimum x value, the maximum x value, the minimum y value, and the maximum y value. And it's going to print those to the console. So here, because obviously it's a point, it's going to have a min and a max of 1.15 on the x-axis, and a min and a max of 2.43 on the y-axis. Okay, and we're able to actually extract, if we do want to, we're able to extract the underlying coordinates. So here, this is basically a Shapely coordinate sequence object that you get when you do myPoint.coords. So this is a Shapely function coords here. It's saying get me the coordinates from my point. And then once you've got that Shapely geometry object set of coords through the coordinate sequence, you can use the list function. And what that's doing is it's basically putting all of those coordinates into a list and printing them to the console for you here. So the first print statement is showing you this coordinate sequence object, and the second one is basically converting those into a list so that you can access them later. So you've basically taken a set of coordinates, you've created a shapely object, you've been able to then do things with that shapely object, like measure distance between things, and now you've been able to kind of extract back the underlying coordinates that you've got, okay? So this is an important building block for how you then do other spatial processing. So let's put some of this knowledge to work. So do make sure that you have a go at this. Once you've had a go, you're then able to kind of watch through this tutorial. I'll give you some of the answers now. So please make sure you try these questions before you watch what I do, otherwise it won't be lodging into your brain at all. Okay, you need to have a go at it and hopefully get it right. If you don't, you need to fail on it. And then when you fail on that attempt, and then I show you how to do it, it's really going to lodge in your brain as to what the correct method is for doing some of these questions. So let's create a new set of points. So we're going to create a set of points, so let's call it my point equals point. And then here what we're going to do is it needs to be a tuple, needs to be 4 and 8, and that worked. So now let's create our second one, so it's my point 2, 2, and 4, okay? Great, so we're able to create those 2 points, and then we're able to print them to our console. Now we can check the different types for these, so remember we can just go .geom underscore type, and that's going to basically check that this is a point and this is a point as well. Okay, so that's a nifty little function there. Now we're able to confirm the area and the length for these different points. So let's start with the area first. So we're going to have an area of 0 for both of our different points, and we're going to have a length of 0 for both of our points. So that's both logical, in line with the spatial geometry model that Shapely has, okay? We're then able to measure the distance between our 2 points. So let's print my point dot distance, my point 2, and it's going to give us a distance between our different points. And we can also check the bounds, okay? So let me go up here. Great. Okay, so that's how you basically get the distance and how you get the bounds of those 2 different points. So look, I'm not going to go further than that right now. I'm going to take a break. I'm going to see you in the next video to do the line sequences, okay? Thanks for tuning in. Goodbye.